part, and then I usually forget to actually pay attention to this. It gives you how to start this. It says by letting f of xy equals 0. So it's setting that whole thing to 0. So effectively what you have is you have a function f written in terms of what variables? X, y, and what? Z. And what is z written in terms of? X and y. Are you with me so far? So what we're going to do is we're going to take the derivative of f with respect to x. So if we actually do this, if we do df dx, partial f partial x, how many paths do we have to x? We have 2 paths to x. Everybody see those 2 paths? So what can you write that as? Well, you can write that as partial f partial x plus, that's that first path right there, plus what? What product do we have next? Partial f partial z times what? Well, partial z partial x, right? Because there's still a choice. There's still a choice right here, right? There's still a choice, so you have to do partial. What's it asking you to isolate right here? It's asking you to isolate partial z with respect to x. So now it's just what? Algebra. But there's one thing, and I made the same mistake in the last class. This right here, I started off by underlining it and then immediately forgot about it. What does that equal? 0. So if you differentiate the left side, if you differentiate that number with respect to anything, what does that come out to be? 0. I literally underlined it with a highlighter, told you to remember it, and then promptly forgot about it myself. So please remember that. So at this point now, what do we need to do? Just algebra, kids. Just algebra. Equals df partial z partial x. And now what do I divide both sides by? The partial f partial z. Exactly. Very good.
Is there a name for that symbol?
Yeah, there's a name. I just like calling it partial. So we end up with partial z over partial x is equal to partial f partial x all over partial f partial c. So which one did we show? We showed this one right here. That's what we just showed. So how do you think you find the other one? Same, but with what? With y instead. Exactly. You do the same thing, but you do it with y. And do you end up with the same exact thing? Absolutely.
Wait.
What?
Sorry.
Did I do it wrong? Go ahead. And it asks you to calculate these 2 second-order partial derivatives. So let's take a look at this first one. This first one is fxy at 1, 2. What does that mean? What does that mean? You're calculating fx at that 1, 2, and then what do you calculate once you do fx?
Fy of that.
Of that, exactly. It's fy of that. It's fy of that. So the best tip I can give you when you're doing a grid like this is to look at the outer one. The outer one on this is y. You're doing fy of fx. This is, I'm doing too many equal signs here. fx, 1, 2, like this. You're doing that is what I want to write. I'll write it like that. Do you remember that notation from yesterday? That's what it means. Mathematicians just like to drop that parenthesis. Okay, so if we're doing fy, like ignore the fact that it's f sub x. If we're doing fy, the partial with respect to y, what does that mean we're fixing? We're fixing x, right. So what point are we dealing with? We're dealing with this point 1, 2, right? If we fix x, if we fix the x value, we're talking about the numbers on this column, correct? Are you with me so far? Okay, so we need to find at each of these points fx right here and fx right there. We need to find out what fx is at both of those points. And the reason I'm choosing those 2 values is I want us to match the numbers that I can clip out of the answer key. Remember how I like to do like before and after values, but the book likes to start at the value and go straight ahead? For now, let's just lock into, when we do these estimates, let's start at the point and go forward once. Is everybody with me on that? I'm doing that for sanity's sake. Looking at these numbers is hard enough. I don't want to come up with 2 different sets of answers at this point. So what that means is we need to come up with fx at both of those points. How do you figure out what fx is at 1, 2? How do you figure that out? It's going to be 9.6 minus 8 over 1.1 minus 1. So that's going to be 1.6 over, which is 16. So how do we go about finding this fx value right here? 10.65 all over 1.1 minus 1. So I think that you end up with like 23 point something. I don't have a name for it, but that's the outer one. So we just calculated the fx values at both cases. So now we're doing fy, which means what do you keep constant? X. So that's what that vertical green line is. So now you have to calculate the change from this fx value to that fx value. So what does that mean? It's going to be what, 22.3 minus what? I think they have it right here. So 22.3 minus 16. And where does that 0.2 come from? 2.2 minus 2. So you end up with what? 31.5. So what did we do there? The key thing to take away, what is the outer, what is the last partial you're taking? You're taking the partial with respect to y. So therefore, what do you have to fix? X. So that's why we have to fix x. That's why I drew that green vertical line right there. But if we need to calculate fx, we need to do it at two different places, where we are and where we're going. We're keeping x the same, so it needs to be at this point and then that point. What changes, and I'm going to just copy this whole chart again because it's going to get too busy. What changes if instead we do the reverse, the outer one? So if x is the outer one, what's changing? X or what's fixed? I mean, what's fixed, x or y? Y is fixed, so it's right here. And again, though, we're going to calculate two different partials. We're going to calculate fy right there, but where else are we going to calculate fy? At where it says 9, we're going to calculate fy right here. We need to calculate fy at those two different points. Fy at those 2 points. How are we going to do that? Well, what do you do with these two numbers? 12.88 minus what? 9.6 all over 0.2. And then you need it right here, so what's that one going to be? 10.65 over, minus 8, over. So those are the two values, right? And what do you do with those two values? Subtract them, and then what do you have to divide them by? You have to divide them by what exactly? The change in what? The change in x, 0. What? 1. If you look at this work, it's kind of annoying when you look at how they presented it in the book because they used a different format for some reason. I don't know why they decided to change it. Maybe because it just fits nicely, I guess. But look how they write it. So they do it all out. We calculated this, we calculated that, and we ended up with these two things, right? And instead of dividing, what did they do? So when I first started looking at that, I was like, where does that 1 over 1, where does that, oh, that's just dividing. That's just dividing. What do you end up with, though? The same thing. Should you end up with the same thing? Yeah, you should. The key to everything, at least in my opinion, is asking yourself, what's the outer partial? And the outer partial on this one is y. So what did we fix? We fixed x. And then you need to find fx at where you are and where you're going, and then find the delta between those two values. There's a lot to keep track of. There's a lot to keep track of. So how about this? This is what I'd like you to do. First, everybody get up to the board. Let's use the whiteboard for the 3. What's the new thing? Or what's that between 1 to 3? What's there that isn't in 1? Z. So when you're doing the grad, you're looking at partial with respect to x, partial with respect to y, and partial with respect to z. So you have to just do these carefully. So if you do these 3, what's fx going to be? Careful. What's fx going to be? What is it? Negative what? Okay, someone raise their hand and then speak with a volume that I can hear. I'm hearing, come on, bring it. What's the partial with respect to x? This is just differential calculus. You absolutely can answer this question confidently. Who can tell me what is the partial with respect to x of this thing right here? Negative sine x. Yeah, so negative e to the y sine x. I'm just reordering it, yes. Comma, what's fy going to be? Yeah, cosine x, e to the y. And what's fz going to be? Guess what you just found? What did you just find? Oh, I know it's not fx. What is that? That is the gradient vector. There it is. That's it.